In this lesson, I will explain how to calculate moles, mass of substance, number of atoms or molecules, volume of gas, limiting reactant, and in the last I will going to explain the empirical formula and the molecular formula. So watch this video till end that you can get very useful information. Calculate number of moles of following. The first question is 50 grams of copper and the second question is 100 gram of sulfuric acid H2SO4 basically. So for the solution of first question I will write the given data, that is 50, mass is given, that is 50 gram, and the atomic mass of copper is 63.5 gram, that will be taken from the periodic table, and this is also called formula mass. Okay, now I will going to write the moles is required and the formula of the mole. The formula of the mole is very simple, that is mass divided by formula mass. So mass is given, that is 50 upon 63.5. so the mole I will get, that is 0.79 moles. Okay, now the solution of second part, again we will write the data. Mass is given 100 gram, and for the formula mass we will going to calculate the formula mass of sulfuric acid into 1 multiplied by 2 plus 1 multiplied by 32 plus 16 multiplied by 4. So this is the way we will going to calculate the mass, that is 98 gram. Okay, now the formula of mole is very simple, mass upon formula mass. So we have 100 gram divided by 98, that is the moles will be 1.02 moles. Okay, now the calculate number of atoms or molecules. So I will explain. Number one question is very simple, that is we have 15 gram of carbon. So what is data? Data is very simple, the mass is equal to 15 gram, and here we will be using atomic mass of the carbon because C represent only an atom. So atomic mass is equal to 12, and as we are using gram atomic mass, so I will write 12 gram. Okay, now what is the requirement? That number of atoms question mark. Okay, next we will write, I will write formula. The formula is very simple, that number of atoms is equal to moles multiplied by Avogadro's number, that is 6.02 exponent 23, and we don't have the moles, so I will expand that moles into mass upon formula mass or atomic mass multiplied by 6.02 10 raised to power 23. Now I will put the values, that is 15 upon 12 multiplied by 6.02 exponent 23. Okay, now I will get 7.5 exponent 23. Now this is the answer. Okay, next let's talk about the next question, that is that let's suppose we have 2.5 moles of carbon dioxide. Okay, now here we have moles, so we don't need any of formula mass, so only I will write moles, that is 2.5, and I will be needing number of molecules because we are talking about the carbon dioxide. Okay, formula is very simple, we already know that the number of molecules will be equal to moles multiplied by Avogadro numbers. Okay, moles we have 2.5 multiplied by 6.02 as 10 raised to power 23, and then I will get 15.05 exponent 23. Okay, now this is the answer. Okay, now I will explain calculation of mass. So how to calculate a mass of substance when moles are given. Okay, now let's suppose I have a first question, calculate mass of 2.9 moles of NaOH. Okay, so given is this equation is moles that are 2.9 and we require a mass question mark. So first I will write the formula. So formula is very simple, mass equals to moles multiplied by formula mass. So we need formula mass of NaOH, so that is 40 around. Okay, so 2.9 multiplied by 40, the answer will be 116 grams. Okay, now next question number 2. Calculate mass of when during a reaction 0.95 moles of HCl produced. Okay, again the given value is moles that are 0.95, and we need a formula mass as well, so it will be 36.5 gram. Okay, so now I will write the formula. Mass equal to moles multiplied by formula mass. So moles are 0.95 multiplied by 36.5. Answer will be 34.67 grams. Okay, now I will explain how to calculate the volume of a gas. Okay, now let's suppose we have a question here. Calculate volume at STP when 0.5 moles of oxygen gas is produced during a process. Okay, now here remember that we have the moles. So first in the data I will write moles equals to 0.5. So what is requirement? That is the volume at STP. Okay, now what is the formula? Formula is also very easy for STP, that volume will be equal to moles multiplied by 22.4. okay, now here as we know that we have formula moles are 0.5 multiplied by 22, then we will get 11.2 dm cube. Okay, now next question number 2. Calculate volume of ammonia at RTP when, or you can say during a reaction 40 grams of ammonia produced. Okay, now here something is different, that we have a mass equal to 40 gram, then we will be needing a gram formula mass, or formula mass, that is for ammonia it is 14 plus 3, that will be 17 gram. Okay, now I will write the formula of volume, that is RTP is required. So formula of the volume is volume equal to moles multiplied by 24, specifically for RTP. Okay, now we have a mass, so we will expand our formula mass upon formula mass multiplied by 24. So right now 40 upon 17 multiplied by 24, so answer will be 56.47. Okay, now the calculation based on balanced chemical equation. HCN can be prepared by the reaction of ammonia with methane and oxygen if reaction vessel contains 51 gram of ammonia. Then calculate the following: mass of HCN produced and the moles of oxygen required. Second, third, volume of CH4 needed for the reaction at STP. Now you can see we have the balanced chemical equation, and this balanced chemical equation basically shows the moles of the chemicals. Okay, now first I will write the given uh, the mass of ammonia, that is 51 gram. Okay, now I will calculate the moles by dividing the mass with the molar mass of ammonia, that is 51 divided by 17 gram. Okay, so I will get moles that are equal to 3. Okay, now I will use the mole ratio to calculate the value of HCN. So for HCN, according to the equation, what we can see, there are ammonia, the given ratio required, that is HCN. Okay, now there are 2 moles of ammonia and 2 moles of HCN according to the equation, but in our question the moles are 3. So for HCN I will just use X here. Okay, and then I will do the calculation by the cross multiplication. I will get 2x equal to 6, and when I divide 6 by 2 I will get x equal to 3. Okay, now these are the moles of HCN that are 3. Now I will write the formula of mass, that is moles multiplied by formula mass. So we already calculated the moles, that are 3, multiplied by formula mass of HCN is if we just calculate 1 plus 12 plus 14. So by the calculation I will get the mass, that is 81 gram. Okay, now I will calculate the moles of oxygen, that is okay. First I will write according to the equation, balance equation basically. So balance equation showing that there are 2 moles of ammonia and 3 moles of oxygen. So I will take the ratio between ammonia and oxygen, the mole ratio, that is 2:3, and according to the given, that is 3 moles of ammonia, then I will use x for the oxygen and do the calculation. After the cross multiplication, 2x is equal to 9 and x will be equal to 9 upon 2, and I will get 4.5 moles of oxygen. Okay, now this is the answer of the second part. Now for the volume of CH4 at STP, okay, again I will use the mole ratio according to the equation, the balance equation, right? So equation is say 2 moles of ammonia is reacting with 2 mole of CH4. So ammonia ratio CH4 both have the same moles. So when I will use 3 moles, so NH4 will be the same 3. Okay, now I have the moles of CH4 that are 3 moles, but I need the volume. So I will use the formula of volume at STP, that is moles multiplied by 22.4 dm cube. Okay, so 3 multiplied by 22.4 dm cube, and the answer I will get 67.2 dm cube. Okay, now the how to identify limiting reactant and excess reactant. Basically this is a type of stoichiometric calculation. Okay, now this is the simple question that 96 gram of sulfur react with 36 gram of carbon according to the following equation. Okay, this is the equation, and we need to identify the limiting reactant, and then we have to calculate the mass of carbon disulfide and the excess amount of reactant in the given equation. Okay, first I will calculate the moles of each reactant. So first for that I am just writing this equation again. The balance equation should be written here. So the mass given of sulfur, that is 96 gram divided by the atomic mass of sulfur, that is 32. Similarly carbon mass is given, that is 36 gram divided by the mass 12. So I will get 3 moles each of these two reactant. Okay, now the second thing I will going to calculate, that is called stoichiometric moles, and with the help of these mole I will going to tell you that which one is limiting reactant. Okay, so I will use the 3 moles of sulfur and divide by the 2 moles that are in the equation, divide by 2, and similarly the 3 moles of carbon divided by 1. You can see in the equation there is only 1 carbon. So what I will get for the sulfur, that is 1.5. For the carbon I will get 3. Now you can see that the moles of carbon are greater than moles of sulfur, so carbon will be excess reactant and the sulfur will be limiting reactant. So this is the shortcut method to determine the limiting reactant and the excess reactant. Okay, the sulfur is limiting reactant. So okay, now for the first part, okay, remember that sulfur is the limiting reactant. Okay, now so we will do the calculation with the help of the mole of the sulfur. So all the calculation will be done by the mole of sulfur only. Okay, now first we have to calculate what is our requirement, that is the mass of carbon disulfide. So according to equation, so I will use the mole ratio of sulfur with carbon disulfide. Sulfur is 2 and the carbon disulfide is 1 according to the equation. In the given we have 3 moles of sulfur, so for carbon disulfide I will assume x. So I will do the calculation, cross multiplication, and when I do the calculation, what I will get, x equal to basically 1.5 moles. Okay, now these are the moles of carbon disulfide. So remember that we need the mass, and so to calculate the amount or mass, we will multiply mole with formula mass of the carbon disulfide. So moles are 1.5, and the formula mass I will going to calculate of carbon disulfide. So that is 12 plus 32 multiplied by 2, basically 12 plus 32 multiplied by 2. Okay, so when I do the calculation, so what I will get 171 gram of carbon disulfide. Okay, now let's talk about the second part, that is how to calculate the excess reactant that will left during the reaction. So for that I will going to take the ratio between the limiting reactant moles and excess reactant moles. Okay, in our equation uh, the limiting reactant is sulfur and the excess reactant is carbon, and the moles of sulfur are in the equation 2, and in the equation carbon 1, but the given mole of reactant are 3, and we will assume carbon as x. So when I do the calculation, so what I will get the value of x, that would be 3 upon 2 equals to 1.5 moles of carbon, that basically the excess reactant will react, and the excess amount which is left, how we will calculate, we will just subtract 3 by 1.5, so that is 1.5 moles. So right now I have just calculated 1.5 moles of excess amount of the excess reactant, that is the carbon. So now I will going to calculate the mass, the excess amount. So how I will calculate the excess amount? The same, moles multiplied by the excess moles multiplied by the formula mass of the carbon. We know 1.5 are the moles, and the formula of the carbon or formula mass of the carbon is 12, so 18 gram answer. Okay, now how to calculate empirical formula and molecular formula. Now we have a question, 1.367 gram of an organic compound contains carbon, hydrogen and oxygen, was combusted in excess of air to produce 3.002 gram carbon dioxide and 1.64 gram water. What is empirical formula? Okay, now the first step, identify elements. So carbon, hydrogen, oxygen already given in the question. Now the second step, find the masses of the element. Okay, now first thing we make the data, that mass of sample we have, that is 1.367 gram, and the mass of carbon dioxide, it is 3.00 gram, and the mass of water we have here, that is 1.640 gram. Okay, now to find out the element mass, first we write the ratio in which the, let's suppose I'm talking about the mass of carbon. So in carbon dioxide there is one carbon out of CO2, so 1 multiplied by 12 divided by 44, 44 is the molar mass of carbon dioxide, multiply by the sample, basically carbon dioxide mass, that is 3.002 grams. Okay, when I do the calculation I will get the mass, that 0.819 gram. Okay, now the mass of hydrogen, similarly in the formula there are two hydrogens, so 2 multiplied by 1, and the molar mass of the water is 18, multiply by 1.64. so I will get the mass of water, hydrogen, that will be 0.182 gram. Okay, now I have calculated the mass of carbon and the hydrogen. Remember that we need 3 elements, but we will going to calculate only 2 masses. So mass of carbon, it is calculated 0.819 gram, and the mass of hydrogen, it is 0.182. okay, now moving toward the third step. Now we will find the percent of each element. So we have a simple way, just to calculate the percentage. The formula is very simple. The percent of element is equal to the mass of element divided by the mass of the sample and multiply by 100. For percent of carbon, so mass is 0.189 divided by mass of sample is 1.367, multiply by 100. So I will get the percentage, that is 59.9%, and the percent of hydrogen will be 0.182 divided by the sample mass 1.367, multiply by 100, percent will be 13.3. okay, now we have percentages of carbon and hydrogen. Percent of carbon is 59.91 and the hydrogen 13.31. so now I will calculate the percent of oxygen, that 100 minus the sum of percent of carbon and the sum of percent of hydrogen. So I will get 100 minus 59.91 plus 13.31. I will get the percent of oxygen will be 26.78. okay, now in the fourth step we will find the mole ratio by dividing the percentage value with the help of their atomic masses. 59.91 divided by 12, 13.31 divided by 1, 26.78 divided by 16. okay, now moles of carbon will be 4.99, 13.31 are the moles of hydrogen, 1.67 moles are of oxygen. okay, now the fifth step, find empirical formula by, basically we can say, by getting the simple mole ratio. okay, we have already the mole ratio, but this is not the simple. so which one is the lowest value? This one, 1.67. we will divide everyone with by 1.67. so with this technique we will able to get simple whole ratio, that is oxygen is in 1, for the hydrogen it is 8, and for the carbon it is 3. so the empirical formula of this molecule is C3H8O. now this is the empirical formula. now let's suppose if molecular mass of the same substance basically is 180 gram, then find the molecular formula. now I just added another part of the question. so first what we will going to do, we will calculate the n, that is the ratio between the molecular mass to the empirical formula mass. okay, we have already molecular mass, that is 180. now I will find the empirical formula mass, that is 12 multiplied by 3 plus 8 multiplied by 1 plus 16 multiplied by 1. okay, it is found to be 60. so I will divide this 180 by 60 and I will get 3. okay, now what I have to do, I have to find the molecular formula by multiply empirical formula with this number 3. so molecular empirical formula is C3H8O and I will multiply by 3. so I will find molecular formula C9H24O3. so this is the molecular formula. Thank you.